Hi, this is Mr. Royks, and I'm going to take you through this problem that deals with the law of definite proportions or definite composition. So we have the problem that tells us we have three samples of a solid substance that contain elements x and y, and so they give us the data in several different forms. The first substance, it gives us grams of x and grams of y. So what we want to do is we want to put that into a ratio. So we're going to say 4.31 grams of X to 7.69 grams of Y. Alright, for the second one, they give us percents. If you look up here, there's percents, and we're just going to change them to grams. So we're going to say we have 35, if we had 100 grams of substance, we'd have 35.9 grams of X over 64.1 grams of Y. And now in the last one, they give us grams of X right there. It's 0.718 grams of X. But what they don't give us is they don't give us grams of Y. They actually tell us that X reacted with Y to form 2 grams of the third sample. So what we have to do is we have to go back to law of conservation of mass, that if we put 0.718 grams of X in and we react with some grams of Y, we get 2 grams of product. So again, law of conservation of matter, whatever goes in has to come out. So that means that we can just set this up like I did, sort of algebraically, and we can solve for Y. So Y is going to be the difference between the 2 and the 0.718. And so that answer, we'll bring that answer down here, is 1.282 grams of Y. So now that we have that last piece of information, basically we're going to simplify these and divide them. And when we do that, we get an answer here of 0.56. We get here an answer of 0.56. And here we get an answer of 0.56. Now, all we have to do is look at these and realize that all of these ratios are the exact same, right? And since they're all the exact same, that tells us that we indeed have established the law of definite composition, okay, or definite proportion, however we want to say it. So all three of these substances do demonstrate the law of definite composition. And that's all you have to do for that problem. Okay, so now we'll look at problem 3, which is on that same worksheet. And so in this case, we are now asked to demonstrate the law of multiple proportions. So really what we do is we set up ratios just like we did before. So we'll look at the first problem, the first substance, which is talking about laughing gas. And it's telling us that, if we have 2.62 grams of nitrogen, okay, that amount of nitrogen will react with 1.50 grams of oxygen. So there's the first ratio. And then we look at the second compound, okay, between nitrogen and oxygen, and that's that in that particular compound we have 0.655 grams of nitrogen, and that is also per 1.05 grams of oxygen. So now the next step is we need to divide, so we get the ratios here. And when we divide these, the top one is going to get us an answer of 1.72. The bottom one is going to get us an answer of 0.44. Okay, and so once we have the ratios, We didn't do it in the last problem because the ratios were the same, so that demonstrated definite proportions. So here what we do is we divide by the lowest ratio. And since we only have 2, we take the 0.44, so we divide both by 0.44. Now obviously 0.44 divided by 0.44 is going to be 1. And then we come up here and we see what we get. We do 0.44. And what we should find, depending on how you rounded things, it's going to be approximately 4. Might come out as 3.99, but 4 is what we could round it to. So the law of multiple proportions states that elements can come together in different fixed number ratios. So obviously the ratio of nitrogen to oxygen, in this case we'll call it a 1-to-1 ratio, and here it's a 4-to-1 ratio. Okay, by mass, that's by mass. So that's all the work that you need to do to solve for that problem. Alright, we'll see you in class.